Okay, today's talk is going to be on sigma and pi bonding. Sigma is going to refer to the end-on overlap between orbitals, and pi will refer to the sideways overlap between two orbitals. So you might have an atom that's got some bonds, and then here's an orbital, here's another atom, similarly, a couple of bonds, and then there's this end-on overlap between them, and so you're going to label that type of interaction as a sigma bond. Then for pi bonding, if you put the atoms close together and draw the p orbitals, then you can show how they overlap. And this drawing represents one pi bond. Another way to represent this is to let the atoms be a little bit farther apart and draw your p orbitals, and then just put lines here indicating sideways overlap, and the two red lines then tell you that this is one pi bond. So we're going to use C2H4 as the example, and put the we're going to do the Lewis structure first. Put the atoms with the Lewis structure, you can have them 90 degrees apart, you can put them 180. And now you want to count your electrons. Each carbon has 4. And then the hydrogen, maybe we'll make that green. Let's see. Each hydrogen has 1. So, first of all, you want to make sure that carbon obeys the octet rule. So draw the circles around each carbon, and how many electrons are there? 2, 4, 6, 7, right? And then this one as well has 7. So you know that you have to correct for this. And let's pick another color here, pink. And in order to create the octet, pull 2 electrons in between the atoms like that. So redo it. 1, 2, 3, 4, and then carbon, hydrogen, single bonds. Those are sigma bonds, by the way, single sigma bonds. And now count again, 2, 4, 6, 8, and 2, 4, 6, 8. So this is going to give, for the Lewis structure, a double bond in the middle. All right. So the next step is to do the Vesper structure. And for the Vesper structure, we look to see how many groups of electrons there are per carbon. You have one group, second group, first group, second group, third group. So there's 3 groups of electrons. And we know from our chart that 3 groups of electrons correspond to sp2 hybridization, and the bond angle of 120 degrees. So to draw the Vesper structure, First, just using the lines for the bonds, we would draw this. You want to put your bond angles in 120 degrees, going all the way around, 120 everywhere. And next, you want to indicate the sp2 hybridization. So you can just draw the 3 sp2 hybrids like that, and you can put your hydrogen, just make them spherical, and you can label them S orbitals. Okay, and then you want to label each of the sp2 hybrids. And then you want to indicate that you have sigma bonding, or that there is sigma bonding. So every time there's end-on overlap, that's going to be a sigma bond. So this would be the sigma framework. That's labeled. Okay, now we're going to write down a rule here, which is that if there's a double bond, this will be made up of 1 sigma and 1 pi. If it's a triple bond, there's going to be 1 sigma and 2 pi. All right. So we have the sigma framework. The next part is to include the p orbitals that are going to make up the pi bond. So we're going to do the pi framework next. And for this, you can go and draw the sigma framework. Just go back to your stick model. It's too confusing to put it all together on one diagram, although students love to do that, and it's fine on a test to do that, to overlap them, but just really see what this is. Next thing you want to do is work out the orbital diagram for carbon, and we know that carbon in the has 4 electrons in the valence shell, 2s2 and 2p2. So the energy diagram is going to be 2s, 2p for the unhybridized carbon. Now you know where you want to go here. You know that you want to have 3 sp2 hybrids. So you want to promote 1 electron up to the p subshell. One, two, three, 4. The next step is to recognize that you're going to have 3 sp2 hybrids to describe the sigma framework. So you have 1, 2, 3. They all have the same energy, sp2. 1, 2, 3. And then you still have 1 p left over, and it's just sitting there. And that p is going to be the basis for the pi bonding. So each carbon has this configuration, and each carbon has a p electron, p orbital that's unhybridized, that's available to do the pi bonding. So together, and now you've got the sigma framework with the correct geometry. And then you want to put in the unhybridized p electron on each carbon. Then indicate that there is a sideways overlap, and then you're going to label that as a pi bond. So ethylene has a double bond. It's got 1 sigma. Let's label it here. Hold on. It's got 1 sigma Actually, these are all sigma, but the double bond consists of 1 sigma, 1 sigma, and 1 pi. All right.